In this video, we are going to look at two special trig limits, and we're going to do a handful of examples that use these two trig limits. So, the two limits, they are the limit of sine of x over x as x approaches 0. That limit is equal to 1. And the limit as x approaches 0 of 1 minus cosine x over x, that limit is equal to 0. So those are two limits, special trig limits. If we tried direct substitution, we would get 0 over 0. And how we handle that, it takes some work. You can look online or look in a textbook, and you should be able to find a full proof of that. For now, for the scope of this video, we are just going to accept that those are true, and then we're just going to use those properties. So, let's look at how we might apply these two special trig limits in a series of examples. In this first example, we have the limit as x approaches 0 of tangent of x over x. If we tried direct substitution, we'd get 0 over 0. And so I don't really know what to do with that. I can't give that an answer or say that it does not exist. I need to do more work to determine that. And right now, we don't have a lot to work with. We have a variety of limit rules. We also have these two special trig limits. So let's see if we can apply one of those. So let's rewrite tangent in terms of sines and cosines. So that tangent of x, we can write as sine x over cosine x. And that stuff was all divided by x itself. So dividing it by x, I'm going to write it as times 1 over x. So we rewrote the tangent as sine over cosine. That multiplication, we could then call that sine x over x times 1 over cosine x. Then using our rules of limits, we can evaluate the limit of sine x over x separately from 1 over cosine x. We can evaluate those two limits separately. And when we evaluate the first one, that is our special limit up here. So we'll have 1. And cosine of 0, if we try direct substitution, cosine of 0 is 1. So we have 1 times 1 over 1, which is just 1 times 1, or 1. And so we applied our special trig limit right here. If we tried direct substitution otherwise, we would get this 0 over 0. And so without this knowledge of this special trig limit, it's tricky. Let's look at a second example. Our second example, here we have 1 minus cosine x over 3x, a limit as x approaches 0. If we try direct substitution, we'll get 0 over 0. So to decide what that's going to be, we have to do more work. Now you might say, oh, it's 0 over 0, so that's just going to be 0. And I would say, no, not necessarily. Our previous problem, it started out as 0 over 0, but its limit was 1. Oh, so then you might say, well, 0 and 0 are the same number, so 0 over 0 is just 1. Is it 1 every time? And the answer is, no, not necessarily. So let's do some work. Let's see if we can get this into one of our special trig limit forms. We can rewrite this as a limit as x approaches 0 of 1/3 times 1 minus cosine x over x. So the 1/3 will stay 1/3. This piece, as x goes to 0, it is going to head towards 0. So we have 1/3 times 0, or 0. Great. So that's what we get. Let's look at two more examples. So we have our same trig limits from up above. Here we have theta approaching 0, cosine theta, tangent theta over 0, over theta. If we do that direct substitution, we will get 0 over 0, so we need to do some work. Let's change that tangents into sines and cosines. There, if we do that, the cosine thetas cancel. So we have a limit as theta approaches 0 of sine theta over theta. This is that first rule, right? We've just changed x, the name of x changed to theta, but it is that first special trig limit. Great. And in the second one, we have limit as t approaches 0 of sine of 2t over t. If we tried direct substitution, we get something that doesn't quite work. We get 0 over 0. Now you might be tempted to say, oh, this limit is just going to be 1, right? However, this requires that the thing inside of the sine, right, the 2t, be exactly the same as what we have on bottom. In here, we have a 2t, but we only have a t on bottom. So we need to get a 2t on bottom. Well, how can we do that? Well, we could do that by multiplying both the top and bottom by 2. And then that 2 we can bring out in front of the limit. And now this 2t, it looks like an x, right? We could replace that 2t with an x. There, as t goes to 0, 2t also goes to 0. And so this we end up with 2 times 1, which is simply 2. You might be tempted to say, oh, can you just take that 2 out in front? And I would say, even though it feels like that's what we did, that's not quite legal. 2 times, so that's just not quite legal. You'll have to be really careful about that. Perfect. In our next video, we will look at a handful of other examples where we are just going to use a potpourri of strategies when we're dealing with limits. We will see you there.